Hey guys, so today we're moving on to 4-4. So today we're going to be able to graph solutions to linear inequalities, and then we're going to also look at a word problem with this. Okay, so 4-4, linear inequalities in two variables. Okay, so what's the solution of the inequality y is less than or equal to x minus 1? Well, this inequality is an example of a linear inequality in two variables. Okay, remember back in chapter 1, we spent some time solving inequalities, but they only had one variable. It's just like x is less than 2x plus 4. Okay, so now we're looking at what happens when we have a y and an x. Well, notice this looks a lot like y equals mx plus b. The only thing that's different is we have an inequality symbol instead of an equal sign. So our solution to this inequality is all ordered pairs that make the inequality true. Okay, so there's more than one answer for this. So we can plot these points on a coordinate plane to understand the solution of the inequality. Okay, so remember, if I had it in slope-intercept form, y equals x minus 1, all the solutions are just the points on the line. Okay, so we're good at graphing this. Okay, start at -1, our slope is up 1 over 1. Okay, so we get the nice line. However, we want to be less than or equal to this line. Okay, if I'm less than, that means I am going under the line. Okay, because anything less than the line would be below the line. Okay, so for every x value, I can be less than it. So I can be down here and down here and down here and down here. Okay, so basically what happens is we end up having to shade underneath the line. Okay, that's where this yellow part comes from. So all of these rays together form what's called a shaded region. The solution of the inequality is all points on the line, which is our boundary line, and the shaded region. Okay, so when we're graphing these inequalities, we have to shade part of the graph. Okay, so let's look at another one. Okay, y is greater than x minus 1. Okay, again, notice not equal, we're greater than this time. Okay, so the process is exactly the same. Okay, we graph the line, so x minus 1, start at -1, go up 1 over 1 for our slope. Okay, but this time I'm greater than. So instead of shading below the line, I'm now going to shade above the line. Okay, notice there's something else that's different as well. Okay, well, this time we have a dashed line. Okay, that is because we're just greater than. If I was greater than or equal to, I would use a solid line. Okay, if I'm just greater than, I use a dashed line. Okay, so just keep in mind, I'm greater than or less than, as I'm going to end up being a dashed line. Okay, remember, it's just like that open circle versus the closed circle. If I'm greater than or equal to or less than or equal to, it's going to be a solid line. Okay. So the points here are not actually part of the solution, just like when we had that open circle with regular inequalities. Okay. And again, our solution here, any point in this shaded region. All right, so let's try one. Okay, please take a minute, pause the video and try letter A. Okay, letter A, we're going to start by graphing my inequality. Okay, so -3x plus 5. Well, I know slope-intercept form start at 5. Okay, -3 tells me go down 3 over 1. Down 3 over 1. Down 3 over 1. Okay, or you could go up 3, left 1. Okay, now I need to decide, is this a solid or a dashed line? Well, we're not equal to, so it's going to be a dashed line. Okay, and then we got to do some shading. I'm less than, so I need to be below the line. So if I put my pen on the line and go down, okay, so that means I need to shade this side of the line. And that is how you do these. Okay, please pause the video and try letter B. Okay, letter B. We start at +5 this time. So 1, 2, 3, 4, 5. Okay, slope is -3. 1, 2, 3 over 1. Down 3 over 1. Down 3 over 1. Or if I'm getting tired of that, I can go up 3, left 1. Okay, solid or dashed line this time. Well, I'm equal to, so it's going to be a solid line. Okay, and where do I shade? Well, I'm greater than, so I shade above the line. Okay, so anything in that purple spot can be a solution to my inequality. All right, so let's learn how to write one of these. So the Science Club sells t-shirts and keychains to raise money. Okay, how many t-shirts and keychains could they sell to meet or exceed their goal? Well, if I look at the picture, okay, I have a $500 goal. I know t-shirts are $10 each and keychains are $2. It's the word problem, so the first thing we always need to do is label our, is to label what our variables stand for. Okay, so we're going to use X and Y. Well, I'm selling t-shirts and keychains, so let's let X be t-shirts and let Y be keychains. Okay, so they want to meet or exceed their goal. Well, the goal is 500. Okay, if I meet the goal, I'm equal to 500. If I exceed their goal, I'm greater than 500. So I want to be greater than or equal to. Okay, so let's talk about X. Well, t-shirts are $10 each, so that's just 10X. Okay, keychains are $2, so that's just 2Y. So this is the inequality I would like to graph. Okay, 10X plus 2Y is greater than or equal to 500. Yeah, I personally probably would not graph this by hand. I would probably use Desmos to do this. Okay, so this is what we're going to be looking at. So I'm going to go ahead and flip the page. Okay, we had 10x plus 2y is greater than or equal to 500. They graphed it for us. Okay, so here's the picture of the graph. Notice this is a solid line because I'm equal to, and I'm shaded above because I'm greater than. Okay. So we want to know if they'll meet their goal if they sell 30 t-shirts and 90 keychains. Okay, so you can either look at the graph and see if that point is in the shaded region. Okay, so 30, 90, I'm not 100% sure because I don't know what this scale is. Okay, I know this would be 120, but 90, is that here? Is it on the line? Not 100% sure. So what we can also do here is plug and chug. Okay, remember t-shirts was X, so I can plug in 30 for X. Keychains is Y, so I can plug in 90 here. And hopefully this is going to be greater than or equal to 500. Well, let's find out. 10 times 30 is 300. 2 times 90 is 180. This 300 plus 180 is 480. Is that greater than or equal to 500? Absolutely not. So we will not meet the goal. Okay, we will not meet our goal here. Right. So now we're going to do it backwards. We're going to write an inequality from the graph. So first thing we need to do is do the y equals mx plus b. Okay, so first thing I need to do is find my slope. So I'm going to pick nice points. Okay, those look like nice points. Oh, my slope's just 1. So I have 1x. Okay, my y-intercept is 1, 2, negative 3. You notice I didn't put equals because we have an inequality. So now I need to decide, okay, am I greater than or less than? Well, I'm shaded above the line, so that means greater than. Am I equal to? Yep, because my graph is solid. So this would be my inequality. Okay, your turn. Pause the video and try letter A, please. Okay, so again, we're going to do y and then mx plus b. Okay, pick 2 nice points. So that looks like a nice point, and that one looks like a nice point. So up 1 over 3. So 1/3 x. Okay, and my y-intercept is 0. So you can put plus 0, but you don't have to. Okay, now am I shaded above or below? I'm shaded below, so I'm less than. Am I less than or equal to? Nope, not equal to because my line is dashed. So there's your answer. Okay, pause the video and try part B, please. Okay, part B, we're doing the same thing, y equals mx plus b. Okay, find some nice points. That looks like a nice point to me. That one looks like a nice point to me. So we go 1, 2 over 1. So down 2 over 1. So that's a negative 2x. Okay, y-intercept is right here at 1. I'm shaded below the line, so I'm less than. And since the line is solid, it's equal to. And there's our answer. Okay, so now let's look at a couple special lines. Okay, we have seen Hoy and Vux lines before. So what happens if we turn them into inequalities? Well, we know what the solution of a one variable inequality looks like on a number line. X is greater than or equal to 3. That's a solid line, and the arrow goes to the right, okay, just like you see right here. Okay, however, we can write this with the y in there as well. Okay, so I don't really care for the way they explain it. We know that x equals 3 is a Buck's line. Okay, that's a vertical line. Well, the same thing happens when we have an inequality as well. Okay, I can go to 3 and do my vertical line. Now, would this be a solid line or a dashed line? Well, this would be solid because we're equal to. So that's where this comes from. Okay, now I'm greater than 3. So am I greater than 3 to the left or to the right? Well, think about a number line. I went to the right, so I'm going to shade to the right. Okay, that's how I would explain this. Okay, same thing happens here. Okay, y is less than 2. Well, I know if I graph that on a number line, here's 2. That's an open circle, and it goes to the left. Okay, if I had y equals 2, I know that that's a Hoy line. Okay, so that's horizontal. So I'm going to go up to where y is 2 and do a horizontal line. Okay, but first, I need to decide, is it solid or dashed? Well, it's not equal to, so it's going to be a dashed line. Okay, so then I got to do my shading. I'm less than. Okay, y. Y is my vertical axis. Am I less than 2 if I go up or if I go down? Well, it's if I go down. So I want to shade below the line. That's how you graph a Hoy line when it's an inequality. Okay, your turn. Please pause the video and try letter A. Okay, well, letter A, it's y, so I know it's Hoy. So I'm going to go down to -2. Okay, and it's horizontal, so I'm going to go this way. Okay, so y is, nope, it's not equal to, so we're going to do a dashed line. Okay, now I got to decide where to shade. I'm greater than. Where is y greater than 2? Up above. So I'm going to shade all the way above the line. Okay, and please make sure you're getting everywhere there. Okay, don't just go above the y-axis. Make sure you get this space too. So that's how you would do letter A. Please pause the video and try letter B. Okay, letter B is a Buck's line. Okay, so I'm going to go to where x is 1, so it's right here. I want to do a vertical line. Okay, it's equal to, so it's a solid line. Okay, and I'm less than. Where is x less than 1? Well, that's just over here. Okay, less than 1. And there's your answer. That's how you do linear inequalities. They're not too bad. It's just like y equals mx plus b. The only big difference is making sure you pay attention to if it's a solid line or a dashed line, and then remembering your shading. Okay. Homework tonight, you are on page 168. Do problems 10, 11, 17 through 27 odd, and 28. Remember, if you have any questions, please be prepared to ask. Okay, send me an email if you need to. Hope you guys have a great day.